This is part 17 of the presentation, The State of the United States Economy and Society. And once again, my name is Edward J. Dodson. This final section is on innovation. To this point, much of what I have presented has centered on the many societal, economic, and environmental challenges we face today. I've offered what I believe are essential systemic reforms, recognizing that the prospects for adoption and implementation of these reforms has insufficient support to overcome the power of vested interest in maintaining the status quo. That said, there are many people bringing forward remarkable innovations that will at least mitigate the destructive consequences of how we have treated the planet as we have industrialized and dramatically increased in number over the last century and longer. Our homes, our places of work, where we shop or engage in almost any activity, are linked together by a complex infrastructure network. That network requires continuous maintenance and periodic replacement. Maintenance and replacement requires public revenue. The subject and issues involved deserve a far more detailed analysis than the examples I present here. But what follows provides some insight into the achievements of how our best, most innovative thinkers are responding to these challenges. We constantly hear about the problem of increasing carbon dioxide in the atmosphere. Here are several new technologies that could lower emissions associated with our construction activities. The potential exists to capture carbon dioxide emissions in a new and unique manner in the production of an eco-friendly type of concrete. The process is the invention of Australian John Harrison. The cement is a composite of magnesite, recycled industrial waste, and ordinary cement. As it sets and hardens, it absorbs carbon dioxide from the atmosphere and converts it to carbonate. To date, however, the cement industry has refused to change its methods. Harrison expresses what he sees as the sense of urgency. I really do not think we have much time left with the atmosphere we have. It is time all the great thinkers of the world, combined with government funding, solve the problem in a manner similar to the way the atomic bomb was created. A January 2024 analysis of eco or green concrete by Ducon Industries confirms increased market acceptance of this product. It has greater strength and durability than normal concrete. Furthermore, the technology is developed in a manner to reduce the CO2 emission related to concrete production, which in effect benefits the construction industry through its massive environmental impact. Green concrete is a blend of cement, sand, pebbles, and other aggregates, which are all eco-friendly. It has zero environmental impact and releases no carbon dioxide into the atmosphere when produced. The wear and tear on the environment are also reduced because green concrete does not require any form of energy to produce it. A researcher at Rensselaer Polytechnic University has developed a process for granulating plastic bags and mix the granules with concrete. Scientists at the University of Adelaide have figured out how to turn plastic bags into a material hundreds of times stronger and 6 times lighter than steel. This material is now being used in electronics and wind turbines and other devices. 10,000 years ago, nearly 60% of the world's habitable land was covered by forest, some 6 billion hectares. Today, only 4 billion hectares remain covered by forest. Forests have disappeared on an area twice the size of the United States. Scientists have concluded that letting forests regrow naturally will protect biodiversity and mitigate the climate crisis far better than planting new trees. Drone reforestation is the utilization of unmanned aerial vehicles to plant trees and restore forests. These drones are designed to map the land, drop seeds, and monitor the growth of newly planted trees. AI drones plant forests 10 times faster using smart seed pod technology. Plastics have proven to be both remarkably useful to modern life and at the same time a major source of pollution and environmental degradation. Replacing non-biodegradable plastics and removing their residue from our land, air, and seas is finally becoming a priority objective of scientists, inventors, producers, and governments. A company founded in 2017, Bifusion Global Inc., has developed a life cycle use for plastic waste that also reduces the need for cement products in construction. The company operates out of a facility in Gardena, California. Here is what the principals say about their products. After years of development for industrial mass production, our patent-pending landfill diversion platform can consistently convert all types of plastic waste into a high-performing, advanced building material called BiBlock. BiBlock enables neighborhoods, corporations, and governments to put their plastic waste to work in their local communities while cleaning up the planet. The Bifusion LDP can create jobs, improve infrastructure, and revitalize neighborhoods based on localized needs. Researchers in Japan have developed a novel type of supramolecular plastic designed to dissolve rapidly in seawater, offering a potential solution to marine plastic pollution. This material is based on two ionic monomers held together by reversible salt bridges. When exposed to the salt in seawater, the plastic breaks down into its original harmless components. Tests have shown dissolution in about 2 to 3 hours, depending on size and thickness. Research shows that extracts from okra and fenugreek can be used to effectively remove microplastics from water. Scientists at Tarleton State University in Texas have discovered that sticky natural polymers, polysaccharides, found in these plants can be extracted and used as a safe, eco-friendly alternative to synthetic chemicals like polyacrylamide, which are currently used in water treatment. Scientists are also investigating the potential to convert plastic waste into useful fuels in what are called continuous and batch pyrolysis reactors that work with a silica alumina catalyst. Sadly, only about 5% of plastic waste in the United States is being recycled, a decline according to Greenpeace from 2014 when the rate was 9.5%. The main problem is a shortage of the costly infrastructure that is required. In particular, rural areas cannot afford to construct the necessary facilities. One of the reasons there is so much opposition to the generation of electricity by nuclear energy is the clear risk of contamination of much of the Earth in the event of a reactor meltdown, the possibility of an explosion, and the widespread release of radioactive poisons. Are there solutions to these problems? The nuclear energy industry has taken steps to find ways of safely storing spent nuclear fuel by moving some of it to dry casks. Typical dry casks are made of steel and concrete, with the concrete providing radiation shielding. To become cool enough to be placed in the dry casks, the fuel must first spend 5 years in a spent fuel pool. By then, it is cool enough that further cooling can be accomplished by natural convection, airflow driven by the decaying heat of the spent fuel itself. Where nuclear power is concerned, the next innovation is one that is coming from the early days of research into how to produce nuclear energy. A real solution may be on the horizon, the development of what is called an integral molten salt reactor. This type of reactor was developed 60 years ago at the Oak Ridge National Laboratory, but shelved because of short-sighted thinking on the part of other scientists, military needs, and energy officials. Remarkably, the process creates much less waste and few long-lived radioactive elements. Moreover, the IMSR's fundamental advantage lies in its most novel feature. The fuel is a liquid. At first glance, that might seem odd, but molten salt, with the uranium dissolved in it, can operate at low pressure and absent are chemical or mechanical driving forces which can cause so many problems with traditional solid fuel reactors. In July of 2024, Kairos Power began construction of a molten salt reactor, the Herms Low Power Demonstration Reactor in Oak Ridge, Tennessee. In May of this year, the first installation of nuclear safety-related concrete was completed. A molten salt battery is a type of rechargeable battery that uses molten salts as the electrolyte. This means that the battery must be heated to a high temperature, typically between 200 degrees Celsius and 600 degrees Celsius, for the electrolyte to be in a liquid state and allow ions to flow between the electrodes. Due to their characteristics like high energy density, long cycle life, and thermal stability, molten salt batteries are suitable for large-scale energy storage. Their applications include grid storage, integrating renewable energy, providing backup power, and use in industrial, military, and aerospace sectors. And as this Denmark model shows, they can provide power up to 100,000 homes with high energy efficiency. The ultimate objective is to prevent plastic waste from entering into our waters. How far out into the future this might occur is not yet clear. In the meantime, cleanup efforts are underway. 19-year-old Boyan Slat has unveiled plans to create an ocean cleanup array that could remove 7,250,000 tons of plastic waste from the world's oceans. The device consists of an anchored network of floating booms and processing platforms that could be dispatched to garbage patches around the world. Instead of moving through the ocean, the array would span the radius of a garbage patch, acting as a giant funnel. The angle of the booms would force plastic in the direction of the platforms, where it would be separated from plankton, filtered, and stored for recycling. Work began in the Great Pacific Garbage Patch, and as of August 2024, the nonprofit had collected over 16 million kilograms, 35.3 million pounds, of trash from aquatic ecosystems around the world. 4Ocean has recovered 30 million pounds of plastic waste and other man-made debris from the world's oceans, rivers, and coastlines since the company began operations in 2017. As of 2024, it is estimated that approximately 1.5 billion cars worldwide are powered by internal combustion engines, which predominantly run on gasoline or diesel. These vehicles will continue in operation for several more decades. Thus, there is urgency in coming up with biofuels to replace fossil fuels and do so at a price competitive with gasoline or diesel. While biofuels can potentially displace fossil fuels in certain applications and contribute to reducing reliance on them, a complete replacement of gasoline with biofuels in all sectors, especially transportation, is not currently feasible. Even converting all available farmland to biofuel production wouldn't meet the current global demand for gasoline. Some scientists have made the case for oil extracted from algae as a future important source of biofuel. Oil yields from microalgae are much greater than from other crops, such as corn or sunflowers. Algae can be grown easily in ponds and swamps, not competing with food crops for land. A report issued in July 2024 by the U.S. Department of Energy examined the economic and environmental sustainability implications of deploying large-scale microalgae farms for cultivation and conversion to biofuels and bioproducts. The conclusions reached were on balance supportive of continued investment in the technology. Traditional wind turbines come with two disadvantages. They create noise and they are a danger to birds. New designs are responding. Energy from wind is now generated by a bladeless technology that uses vorticity, an aerodynamic effect that produces a pattern of spinning vortices. The cone is made from a composite of fiberglass and carbon fiber, which allows the mast to vibrate as much as possible. There are no gears, bolts, or mechanically moving parts. The cone captures 40% of the wind's power when the wind is blowing 26 miles per hour. As of today, there are currently very few commercially available bladeless wind turbines, with most being in the prototype stage. The most well-known company, Vortex Bladeless, has only a handful of small-scale operational prototypes like the Vortex Nano and Vortex Tacoma, primarily used for research and demonstration purposes, not large-scale power generation. Urban Green Energy has just launched a new 1 kilowatt wind turbine designed specifically for city rooftop use. The near-silent Eddy GT turbine rotates on a vertical axis, optimizing wind capture even as the airstream shifts within the dynamic city landscape. Swedish company Home Energy recently revealed an innovative wind turbine that spins in a spherical formation. Eschewing traditional rotors for a sleek orb structure, this design utilizes the Venturi principle, which funnels wind within the turbine's blades. The resulting spherical wind turbine features increased efficiency and lower noise levels, making it ideal for small-scale energy needs such as personal home use. Catrick Technologies out of Glasgow, Scotland, has developed a honeycomb-shaped wind turbine that is significantly more compact than those with blades. They can sit on already existing buildings and so are compatible with urban development. They use oscillating aerofoils to capture wind. This spinning photovoltaic cone generates 20 times the electricity as an equivalent solar panel. This technology has been developed in the Netherlands for use in the residential market. Our homes and many buildings now use solar panels to generate electricity. Solar farms exist in places where the sun shines almost every day. Well, what's next? These mirror dishes are the newest innovation in solar energy. The dish captures 34% of the sun's energy compared to 23% for most solar generators. To generate the same amount of electricity burning coal, 81 metric tons of CO2 would be released into the atmosphere. Tesla is now manufacturing solar panel shingles for homes. Tesla's major innovation is to make the active solar shingles look the same as all other non-active roof tiles. The cost is around $21 per square foot, which is very competitive to standard roofing shingles. The total cost for a 2,500 square foot home would be around $50,000. The global solar shingles market was valued at $326.2 million in 2021 and is projected to reach $555.2 million by 2031. And then there is the fairly recent development of solar film. The U.S. solar film's market size was estimated at $916.26 million in 2023 and is projected to register a compound annual growth rate of 6% from 2024 to 2030. The installation of solar panels over canals not only generates electricity, but prevents the evaporation of valuable water supplies. However, there are great costs and engineering challenges associated with covering waterways with solar panels. The wider the canal and the more distant it is from transmission lines, the higher the price tag and the narrower the benefit margin. In fact, some water supply experts doubt significant gains are to be had. Installing solar panels over crops, known as agrovoltaics, is a growing trend that combines solar energy production with agricultural activities. This approach can offer benefits for both agriculture and renewable energy, including increased crop yields, soil moisture retention, and potential economic advantages for farmers. New advances in solar panel technology include perovskite solar cells, bifacial panels, and tandem solar cells, offering increased efficiency, lower costs, and flexibility. These innovations are pushing the boundaries of solar energy generation, moving towards more sustainable and cost-effective solutions. Additionally, thin film panels, transparent panels, and innovative materials like biohybrid solar cells are also being explored. This system, invented by Filipino student Carvey Maigu, absorbs ultraviolet light from sunlight even if it's cloudy and converts it into electricity. Producing energy is only half the challenge. Storing the energy to be drawn upon as needed is experiencing rapid change as well. Mike Zimmerman, owner of Ionic Materials, has invented a lithium-ion battery that will not catch fire. His battery is a solid lithium polymer metal battery that solves the problem of preventing battery electrodes from contacting each other directly, starting a fire. Unfortunately, I learned that in June of 2024, Zimmerman's firm shut down. The reasons have not been revealed. It could be because of new competition. In 2024, battery technology developments include solid-state batteries, lithium-sulfur batteries, and flow batteries. These innovations aim to improve energy density, charging speed, and lifespan. Lithium batteries are very difficult to recycle and require huge amounts of water and energy to produce. Emerging alternatives could be cheaper and greener. Sodium-ion batteries are a promising alternative to lithium-ion batteries. Sodium-ion batteries are rechargeable and operate similarly to lithium-ion batteries. The advantages are explained by James Quinn, Chief Executive of Faradion, a UK-based battery technology company. Sodium is a much more sustainable source for batteries than lithium. It's widely available around the world, meaning it's cheaper to source and less water intensive to extract. It takes 682 times more water to extract 1 ton of lithium versus 1 ton of sodium. That is a significant amount. Samsung's solid-state EV battery breakthrough promises a 600-mile range with a 9-minute charge and a 20-year lifespan, offering a significant leap forward in EV technology. These solid-state batteries, which use solid electrolytes instead of liquid ones, offer higher energy density and enhanced safety compared to traditional lithium-ion batteries. While initially focused on super premium EVs, they have the potential to revolutionize the EV industry. China has launched its first large-scale lithium-sodium hybrid energy storage station in Yunnan province, combining lithium and sodium-ion batteries to improve cycle life, response speed, and temperature stability for renewable energy integration. Recent advancements in fusion energy research include record-breaking sustained fusion energy generation in the JET tokamak. new breakthroughs in plasma confinement and density limits, and the development of innovative approaches to fusion like magnetic target fusion. These developments are moving the field closer to achieving scientific break-even and ultimately commercial fusion power. The International Thermonuclear Experimental Reactor is decades in the making and is humanity's leading effort to harness the energy that powers the sun. ITER announced this week that the Central Solenoid, the world's most powerful magnet and beating heart of the tokamak, is finally complete and will begin assembly soon. Recent advances in photovoltaic power focus on enhancing efficiency, exploring new materials, and broadening applications. These advancements include high-energy perovskite solar cells, bifacial solar panels, and advancements in energy storage. The Wenzhou Taihan 550 megawatt project, which combines floating solar with aquaculture, has been officially connected to the grid in East China. The power station is expected to provide 650 million kilowatt of clean power to the grid each year, enough to supply power for 130,000 households. Coconut shells, often discarded after consuming the fruit, represent a significant amount of waste. Improper disposal can lead to environmental problems like mosquito breeding grounds and pollution, but they also offer valuable potential for reuse and upcycling. A visionary man has found a way to use waste coconut shells to create shipping pallets, aiming to save 200 million trees every year. Instead of relying on wooden pallets, this innovative idea repurposes a material that would otherwise go to waste, creating a solution that benefits both the environment and industries. In the United States, approximately 391.9 million metric tons of asphalt are produced annually for road construction, while concrete used for roads and bridges is around 233.3 million metric tons, according to the Department of Energy. This includes reclaimed asphalt pavement and recycled concrete aggregate, which are also used in road construction. A company in India is now mixing plastic from landfills with asphalt to form a compound that can be used in road construction. Nearly 1,000 miles have been constructed to date with this material, which wears better and lasts longer than traditional asphalt. The only main concern most experts have with using plastic in road paving is the concern of spreading microplastics and polluting the air. Heating plastics can often release toxic fumes, but Advanced Plastiform Inc., the firm that has developed the plastic asphalt, insists that because PET and PVC are excluded and the temperature is highly controlled, the plastic isn't giving off fumes during the process. In addition, while traditional pavement is ground up and reused at a later time, using plastic waste allows for an immediate recycling process. The pavement is milled, pulled into the machine, and is mixed with melted plastic on site, creating a road that is not only 100% recycled, there's no turnaround time for recycling. What's taken up is reused immediately, eliminating the need to carry and store old asphalt concrete to use at a later time. In the U.S., approximately 2.8 million acres of land are dedicated to growing rice. This rice production is concentrated in 6 states: Arkansas, California, Louisiana, Mississippi, Missouri, and Texas. Rice is a major agricultural sector in the U.S., producing 20 billion pounds annually and contributing over $34 billion to the economy. Adding fish to rice fields, a practice known as rice fish culture, offers a win-win for both farmers and the environment. Fish act as natural pest control, improving oxygen circulation, and even fertilizing the soil with their droppings, leading to increased rice yields. Additionally, fish can help reduce methane emissions from rice fields, a significant greenhouse gas. Another innovation gaining traction is using the movement of water to generate electricity. Electricity is now being produced by osmosis, the passage of water from membranes, generating a pressure difference that can be harnessed to generate power. The first power plant using this system began operation in 2009 in Norway. Today, 2 other projects are being developed, in Japan with a pilot plant in Fukuoka, and in the United States. An osmotic power plant cannot be built just anywhere along the coastline. It needs to be close to reservoirs of fresh water and seawater. Consequently, the mouths of rivers are the only locations where such plants can be located. In practice, in an osmotic power plant, a network of pipes conveys fresh water and seawater into different chambers, separated by a membrane. Tidal energy harnesses the power of the natural rise and fall of ocean tides to generate electricity, using specialized generators in suitable locations. Tidal currents, with enough energy for harvesting, are found where water passes through a constriction, causing the water to move faster. It turns out it's actually possible to produce engine-ready gasoline from air. This is accomplished by removing carbon dioxide and hydrogen from the air and combining them into a hydrocarbon. A New York-based startup called Aircela has developed a machine capable of generating usable gasoline directly from the air. This machine combines direct air capture with on-site fuel synthesis to create gasoline using just air, water, and renewable energy. It is estimated that over 300 million golf balls are lost or discarded in the United States every year. Many of them end up in lakes, rivers, streams, and the oceans. A golf ball will decompose naturally in somewhere between 100 and 1,000 years. Some communities and environmental activists are beginning to do something about the problem. And the problem worldwide is really huge. A sonar search of Loch Ness in Scotland in 2009 found over 100,000 golf balls. Golf balls contain zinc and other heavy metals that could potentially escape into the surrounding water. Recovered balls are being sold online for half the cost of new ones. Advancements in hydrogen power development are centered on efficient production, reliable storage, and widespread fuel cell applications. Green hydrogen production through electrolysis is becoming more cost-effective and scalable. Hydrogen storage technologies like solid-state materials and advanced containers are also improving. Fuel cells are advancing in efficiency, durability, and application possibilities. Germany is a leader in the development and deployment of hydrogen-powered passenger trains, with several routes now operating using this technology. Development is well underway with a viable prototype already rolling on the road. There are challenges facing Toyota besides the dearth of hydrogen fuel infrastructure worldwide. One of them involves improving the efficiency of hydrogen fuel combustion. Also called renewable hydrogen, green hydrogen is obtained by electrolysis of water. The most crucial thing is that this process is powered entirely by renewable energy, so it generates no polluting emissions into the atmosphere and is the cleanest and most sustainable hydrogen. Water power already produces an enormous amount of energy, turning turbines at the base of huge dams. A lesser-known engineering innovation also produces electrical energy by pumping water uphill to a reservoir, then releasing it to flow back through turbines at the base of a lower-level lake. This technique is called off-river pumped hydro energy storage. When there is excess electricity, water is pumped through a pipe or tunnel to the upper reservoir. The energy is later recovered by letting the water flow back down again through a turbine that converts it back into electricity. Efficiencies of 90% in each direction are possible. Pumped hydro is by far the most widely used form of energy storage, representing 99% of the total. Used in conjunction with solar farms, the total cost is calculated to be much lower than using batteries for storage of electricity. Brazil is leading the charge in sustainable infrastructure by turning sugarcane waste into durable, eco-friendly roads. Researchers have discovered that sugarcane ash, a byproduct of sugar production, can replace traditional stone dust in asphalt mixtures, making roads stronger, longer lasting, and more environmentally friendly. Early highway trials are yielding impressive results, suggesting that this new asphalt could transform how the world builds roads, infusing each mile with a dose of sustainability without compromising on strength or cost. Ships powered by alternative fuels such as liquid and natural gas, methanol, biofuels, hydrogen, and battery power are becoming increasingly popular as the shipping industry seeks to reduce its environmental impact. These fuels offer lower emissions compared to traditional fossil fuels and can help meet international regulations. The adventure cruise company Hurtig Gruen Norway is developing a zero-emissions electric cruise ship with retractable sails covered in solar panels. They anticipate it will be ready in 2030. This ship, chartered by Cargill, embarked on its maiden voyage in August of 2023. The ship is fitted with two Wind Wings, large steel sails designed by the UK company Bar Technologies. The use of the steel sails generates emission savings of up to 30%. There are a growing number of regions in the United States where rainfall or mountain snowfall in winter is becoming less and less reliable. Drought conditions are affecting agriculture and industry. There is mounting pressure on communities to enact strict water conservation measures. Recycling water reduces the strain on freshwater sources such as rivers and lakes by providing an alternative water supply for various non-potable uses like irrigation and industrial processes. This conservation of fresh water is crucial in regions facing water scarcity or droughts. Rainwater harvesting involves collecting and storing rainwater for future use. In urban areas, rooftop systems gather rainwater, reducing the strain on municipal water supplies. This method can meet up to 50% of a household's water needs. Installing these systems helps communities better manage water shortages, especially in water-scarce areas. Gray water recycling reuses water from sinks, showers, and machines for irrigation and toilet flushing. Studies show that household water can be recycled by up to 60%. This method reduces water consumption and minimizes the load on sewage systems. By using gray water for landscaping, homes can reduce their freshwater use by as much as 30%. Groundwater recharge uses methods to direct excess surface water into the ground, replenishing aquifers. This is done through recharge wells, infiltration trenches, and natural ponds. With groundwater levels falling and 70% of people depending on it, this method is essential. Groundwater recharge can occur naturally or through artificial means. Natural recharge occurs when rainwater seeps through the soil and replenishes underground aquifers. This process is influenced by factors like soil type, vegetation, and landscape slope. Watershed management involves managing and conserving land and water resources within a watershed, a region that drains waterfalls into a common source, like a river or lake. It aims to protect the health of the entire water system, like rivers, lakes, and groundwater. It involves soil conservation, afforestation, and rainwater harvesting at a large scale. Proper watershed management helps prevent floods, droughts, and soil erosion. In Japan, a sink is built above the toilet tank for hand washing. The water drains into the toilet tank to be used for next flush and saves millions of gallons of water each year. Important in a world where individuals continue to travel one or a few at a time in individually operated vehicles is the next generation of alternatively powered vehicles. Sometimes called pneumatic hybrid electric vehicle, these cars are most typically powered by a compressed air engine combined with an electric motor. The engines are similar to steam engines, as they use the expansion of externally supplied pressurized gas to perform work against a piston. Researchers have developed lightweight supercapacitors that can be combined with regular batteries to dramatically boost the power of an electric car. The supercapacitors, a sandwich of electrolyte between two all-carbon electrodes, were made into a thin and extremely strong film with a high power density. The film could be embedded in a car's body panels, roof, doors, bonnet, and floor, storing enough energy to turbocharge an electric car's battery in just a few minutes. Toyota's Prius Prime remains one of just a few automobiles introduced with a solar panel built into the roof. This roof will not only help to charge the Prius main battery, but it can also power accessories such as the air conditioning while you're driving, provided there's enough sun to do so. Hyundai and Nissan offer automobiles with similar capabilities. SunSwift 7, a solar-powered race car designed and built by engineering students at the University of New South Wales, Sydney, in 2022 set a record when it became the first solar electric car to cover 1,000 kilometers, 621 miles, in under 12 hours. The next great innovation in air travel is the introduction of electric motors to replace jet engines. A Los Angeles firm named Ampere has developed this hybrid electric aircraft. This aircraft is a retrofit of a Cessna 337, which has a forward-mounted prop engine that pulls and a rear-mounted prop engine that pushes. One of the two internal combustion engines is replaced with an electric motor powered by batteries. The aircraft will seat 4 or 6 passengers. Rolls-Royce's electric plane, Excel, or Spirit of Innovation, had a test flight in 2021, reaching a top speed of 555.9 kilometers per hour over 3 kilometers. The aircraft was propelled on its record-breaking runs by a 400 kilowatt electric powertrain and a power-dense propulsion battery pack. Airbus EFan 1.1 was the first electric plane to cross the English Channel in 2015. It is a light two-seat craft powered by lithium-ion batteries and 2 electric motors. Wright Electric is working on a 100-seat fully electric regional jet that could take off starting in 2026. The Wright Spirit is a conversion of the BAE 146 regional jet, destined for 1-hour flights. Hydrogen-powered aircraft, also known as hydrogen fuel cell aircraft, utilize hydrogen as a fuel source, either through combustion or fuel cells, to power electric motors that drive propellers. This technology aims to decarbonize aviation by reducing greenhouse gas emissions. How we live and how we make use of the land and natural resources is also being reimagined. One example is a new Florida community called Babcock Ranch, developed by former NFL player Sid Kitson. Babcock Ranch is located 15 miles from Fort Myers, Florida, on 17,000 acres of land where the power source is 350,000 solar panels. Kitson's firm purchased a 91,000-acre ranch in 2006, out of which 73,000 acres was sold to the state of Florida for preservation. Another 440 acres was donated to Florida Power and Light Company, which then spent $100 million on the solar farm. As of May 2023, the community had grown to 3,000 residential properties. An article in the journal Science argues that the most important thing we can do to remove carbon dioxide from the atmosphere and at the same time stop the extinction of plant and animal species is to plant trees. It would cost under $300 billion to plant 1 trillion trees. The one shortcoming of this strategy is that most trees grow very slowly. A better alternative under consideration is the widespread cultivation of industrial hemp, the non-intoxicating form of cannabis. Industrial hemp has numerous practical uses and grows to 13 feet within just 100 days. It absorbs more CO2 per hectare than any forest or commercial crop. Land dedicated for the growth of industrial hemp in the United States in 2023 was around 28,000 acres. This has increased to cover 54,000 acres today. Dry farming, also known as dry land farming, is a method of cultivating crops without irrigation in regions with low rainfall. It relies on the natural moisture in the soil and specific farming techniques to sustain crop growth. This approach minimizes water usage and can lead to more concentrated flavors and nutrients in the produce. Kiera Nugent won the Google Science Fair Community Impact Award for her innovative creation of a super absorbent biodegradable polymer made from orange peels. She devised a groundbreaking way of keeping crops hydrated for longer and at an affordable cost. By using orange peels and avocado skins, Nugent produced a super absorbent polymer that carries approximately 300 times its weight in liquid relative to its own mass. An Oregon farmer has been experimenting with new techniques for growing vegetables without irrigation or watering the plants. The soil surrounding seeds and transplants is compressed to start capillary action, lifting soil moisture to the surface to germinate seeds and encourage roots. As the growing season continues, the plants send roots deep to harvest receding water. The indoor farming market is a rapidly growing sector, projected to reach significant revenue by 2033, with a return of approximately 13%. In 2024, the market was valued at $45.97 billion and is expected to reach $138.09 billion by 2033. Inventors are looking at how to make the electric motor more efficient. A high school student in Florida has produced an enhanced synchronous reluctance motor that has much greater rotational force or torque and efficiency than existing ones. The motor uses no rare earth minerals. Might we someday no longer need to harvest timber in order to make use of wood? Researchers at the Massachusetts Institute of Technology pioneered a technique to generate wood-like plant material in a lab. The process could enable a manufacturer to grow a wooden product such as a table without needing to cut down trees or process lumber. Approximately 3% of the Earth's water is fresh water. The remaining 97% is salt water, primarily found in oceans. Of that 3% fresh water, the vast majority is locked up in glaciers and ice caps or exists as groundwater. Only a small portion, about 0.3%, is readily available in surface water like lakes and rivers. A team of researchers has developed a graphene-based filter so advanced, so precise, it can sieve salt at the molecular level, allowing only pure water to pass through. When salt dissolves in water, its ions, like sodium and chloride, are wrapped in a shell of water molecules. These shells make the salt bulky, much larger than a single water molecule. That's critical, because the graphene oxide membranes developed by scientists at the University of Manchester are engineered with nano-sized pores that are just big enough for water molecules to pass through, but too small for the larger shell-covered salt ions. Water slips through, salt gets left behind. What about purifying water? What are we doing there? The seeds of this ancient tree have been used to purify water and clean crockery since the days of ancient Egypt. But up until now, scientists weren't sure exactly how they worked. Thanks to a new paper published in the journal Langmuir by researchers at Pennsylvania State University, part of the mystery has now been solved. And with that, we're finished for now. There's certainly much more to talk about, much more to research, and I hope to prepare an additional update at some point in the future. Until then, thanks.